In this video, I will explain monostable multivibrator using Opamp. Monostable multivibrator using Opamp. Using Opamp. The monostable multivibrator is also called as the one-shot multivibrator. The circuit produces a single pulse of specified duration in response to each external triggering signal. Initially, the monostable multivibrator is in permanent stable state. At that instant, the output of the monostable multivibrator is plus V set. Plus V set. This is the transfer characteristics curve of the op-amp. Plus V set and minus V set here. Plus V set. This one is minus V set output. This is the trigger pulse. Some trigger pulse is applied here. The trigger pulse is applied here. Here some trigger pulse applied here. Change the state of the monostable multivibrator from permanent stable state to quasi stable state. That means minus V set. Minus V set. The monostable multivibrator is in quasi stable state in the time interval capital T. In the time interval capital T. After the capital T time interval, automatically changes. That means without any trigger signal, automatically it changes to permanent stable state. Again, a trigger pulse, negative going trigger pulse is applied here. Negative going trigger pulse is applied here. The state changes like that. The changes state is stated changes from plus V set to minus V set like that here. It remains in that quasi stable state. In that time interval is capital T. After that, automatically changes after time interval T. Automatically changes to permanent stable state. For each and every trigger pulse, a single pulse of specified duration is produced. This is the single pulse. For each trigger signal produces, the circuit produces a single pulse of specified duration in response to each external triggering signal. The monostable multivibrator is also called as the one-shot multivibrator. One shot means for each single trigger pulse, it produces single pulse of specified duration. The circuit produces a single pulse of specified duration in response to each external trigger signal. These are the two external trigger signals. For such a circuit, only one stable state exists. This is the one stable state. One stable state exists. When an external signal is applied, this is the external signal, negative going pulse is applied, the output changes its state. The output changes its state from plus V set to minus V set. The new state is called as a quasi-stable state. This state is called as a quasi-stable state. The state is called as quasi-stable state. The circuit remains in the state for a fixed interval of time. This circuit remains in the state for a fixed interval of time, capital T. After some time, it returns back to, without any external signal, without any triggering signal, it returns back to its original stable state. Original stable state. This is called as permanent stable state. This is the temporary stable. Quasi-stable state means is called as a temporary stable state. After a predetermined time t, fixed interval of time t, it go back to original stable state. The trigger pulses are obtained by differentiating the square wave. Later we will see. Here, this is the circuit diagram of a monostable multivibrator. Non-inverting plus is non-inverting terminal, minus is inverting terminal. This one is RL, this one is R naught. This is the positive feedback. Positive feedback consists of two elements, R1 and R2. This is the voltage divider circuit. Is connected to non-inverting terminal of the op-amp. Inverting terminal of the op-amp is connected to R and C elements. This is the R and C elements. Across C elements, diode D is connected here, shown in figure. Here, this is the differentiator circuit. The differentiator circuit consists of C3 and R3. This is the point X here. This is the point X. At the output of the differentiator circuit is a square wave is applied to differentiator circuit. Output of the differentiator circuit is a positive going spikes and a negative going spikes. Positive going spikes and a negative going spikes. For the operation of this monostable multivibrator requires either positive going pulse or negative going pulse. This can be achieved. The diode used here must be forward biased. The diode used here must be forward biased. In this figure, the diode D is forward biased for negative going pulses only. For positive going pulses, the diode is reverse biased. This is the point Y. This is the point Y. The triggering pulses are like that. Negative going triggering pulses, not positive going triggering pulses. For positive going triggering pulses, the diode D is in reverse bias condition. The output of the monostable multivibrator is at maintained two states, plus or minus Vset, 2 voltage, plus or minus Vset. Plus or minus Vset. Due to initially without any input signal, the power is switched on. Output voltage is equal to VOOT. VOT means output offset voltage. This output offset voltage is amplified and appeared at the output of the monostable multivibrator. This is VOOT. This is positive. That is the reason the output is plus Vset. Consider a transfer characteristic curve of the op-amp. For positive voltages, the output is plus Vset. For negative, it is minus Vset. Minus Vset. Initially, the output voltage of the op-amp is plus Vset. Consider this one. Minus plus. Without any trigger signal is applied here. This one is R1, R2, RL, V0. This one is R. This one is C. Diode D. VD voltage here. This one is VC voltage. V0 is equal to plus Vset. V0 is equal to plus Vset. Therefore, Here the voltage is V1. Here the voltage is V2. V1 is equal to output voltage is Vset. The Vset voltage is applied to this divider circuit, voltage divider circuit, plus Vset into R2 by, not R2, R1 by R1 plus R. Therefore, V1 is equal to R1 by R1 plus R2 is beta. Vset into beta plus Vset beta. The value here V1 is beta V saturation, V1 value. Due to this plus Vset, the diode D is forward biased. The diode D is forward biased. Therefore, across that diode capacitor is connected. Whenever the diode is forward biased, the voltage is VD is equal to 0.7 volts. Therefore, VC is also 0.7 volts. Therefore, V2 is equal to 0.7 volts. Here the difference voltage VAD is equal to the difference voltage VAD is equal to V1 minus V2. V1 is beta Vset. Beta Vset. My V2 is 0.7. This one is positive. This one is positive. Therefore, output voltage is equal to gain into VAD. Gain into VAD. Whenever the difference is positive, this V0 is also positive. This Y0 is positive. That is plus Vset. That is the stable state. That is the stable state. Now we will see in graphs. Here trigger signal, here trigger signal. Here trigger signal, initially the trigger signal is represented is at high level, not applied here. Next one is capacitor signal, capacitor voltage. Capacitor voltage here VC. Next one output voltage, output voltage V0. Here, whenever the power is switched on, the output voltage V0 is equal to plus Vset. The output voltage V0 is equal to plus Vset. Here plus Vset, here plus Vset. At that instant, this is the time. At that instant, that the diode D is forward biased. The voltage is VD is equal to 0.7 volts. Therefore, VC is equal to 0.7 volts. VC is equal to VD. VC is equal to VD. That is 0.7 volts. 0.7 volts. 0.7 volts. VD is equal to 0.7 volts. Okay. Next. This is the output of the monostable multivibrator Z plus Vz. This one is called as permanent stable state. How to change this state is very, very important by applying external trigger signal. By applying external trigger signal, here a differentiator circuit is used to differentiate the square waveform. Spikes are produced like that, positive going spikes and negative going spikes. For the operation of the monostable multivibrator requires only one polarity, either positive polarity or negative polarity. This can be done with the help of this diode. The diode must be forward biased. For negative going pulses, the diode is forward biased. Therefore, here the diode is short circuited. Positive negative going pulses are reached to V1. Negative going pulses are reached to V1. Therefore, the change permanent stable state changes to quasi stable state. Now we will see that behavior of the monostable multivibrator. Now we will see the behavior of the monostable multivibrator. Here again, now draw this circuit. Minus plus R1, R1, R2, V0, RL. Here some negative going pulses are reached here to this point here. Here some resistance R, timing circuit. Here some capacitor C. Here VC. (0.7 volts). VC is equal to 0.7 volts. Okay. We know that VD difference voltage VDA is equal to, this one is V1 minus V2. V1 is already V1 is equal to beta V0 minus 0.7 volts. When V0 is minus V, change state means the output of the monostable multivibrator is changes from plus Vsat to minus Vsat, plus Vsat to minus Vsat. How to change that state? Now I will explain. This negative going pulse is reached to here. This pulse amplitude is Vt. Pulse amplitude is Vt. Vt is negative. Vt is negative. Therefore, V1 is equal to Vt. That means it is negative. Vd is equal to Vdi. Difference voltage is V1 minus V2. Negative minus negative. That is negative. Therefore, output voltage A0 is equal to gain A into Vdi. That negative voltage is amplified. Therefore, output voltage V0, Vdi is negative. Output voltage is also negative. Therefore, output is minus Vset. Output V0 is equal to minus Vset. Due to that, triggering pulse is applied. Now find out this point here. This voltage. Previously, V1 is here. A negative triggering pulse is applied here. Now this voltage V1 is equal to minus Vsat into, due to this effect, the output voltage V0 is equal to minus Vsat. Minus Vsat into R1 by R1 plus R2. That negative going voltage is override with this voltage V1. Therefore, V1 is equal to minus Vsat into beta. Minus Vsat into beta. V2 is 0.7 volts. V2 is 0.7 volts. Due to that negative voltage minus Vsat, the capacitor is already the capacitor is charged to 0.7 volts. The capacitor is charging towards minus Vsat voltage negatively. Minus Vsat negatively. These things are indicated in this diagrams. First of all, a negative going trigger pulse is applied here. This one negative going trigger pulse is applied with pulse duration is Tp. Pulse duration is Tp. Due to that pulse duration Tp, here output change from plus Vset to minus Vset, plus Vset to this one is minus Vset, plus Vset to minus Vset. At that instant, this one is this V1 is equal to minus beta Vset. V1 is equal to minus beta Vset. At that instant, the capacitor is the capacitor voltage is discharges negatively towards minus Vset. Towards minus Vset. But here some whenever the capacitor voltage reach to minus beta Vset, minus beta Vset negatively, minus beta Vset line is also important here. Minus beta Vset line. Whenever the capacitor voltage charges towards negatively and reaches to minus beta Vset and reaches to minus beta Vset. Whenever the capacitor voltage reaches to minus beta Vset, here the difference voltage VID is equal to V1 minus V2. Therefore, V1 is minus Vset beta or minus beta Vset. V2 is just crosses minus beta Vset negatively. Negative into negative, that is positive. Negative into negative, positive. Therefore, V2 is greater than minus beta Vset. Therefore, VID is positive. VID is positive. Voltage output voltage is equal to gain A into VID. That is V0 is positive. V0 is positive means V0 is equal to plus Vset. V0 is equal to plus Vset. Just whenever the capacitor voltage just crosses this minus beta Vset, therefore output voltage changes state. Output voltage changes state. Change state to plus Vset. Plus Vset. This is the specified time interval T. That without any external signal, the state of this change has been observed from quasi-stable state to permanent stable state. This one is stable state. This one is quasi-stable state. How to transition takes place from stable state to quasi-stable state? By using some trigger signal here. By using some trigger signal. After a specified time interval T, automatically change from quasi-stable state to permanent stable state. Permanent stable state. After that, the capacitor voltage, therefore, output voltage is equal to plus Vset. After discharging, this VC voltage is not 7.7 volts. Again, the capacitor is charges. Again, the capacitor charges to this point. The capacitor charges up to this point. And clamps that the diode D is forward biased and the clamps that voltage is 0.7 volts. This is the operation of the monostable multivibrator. Next one, find out this time period. Find out this time period. Pulse duration T is greater than this is T is greater than TP. T is greater than TP. In the circuit diagram, this is the low pass RC circuit. This one is low pass RC circuit. Here some important point here is the general solution for a single time constant low pass RC circuit with Vi and Vf as initial and final values is V0 is equal to Vf. Vf is the final value, Vi is the initial value. Vf plus Vi minus Vf e power minus t by RC. Now from this diagram, here Vi is equal to Vd. The capacity is charges negatively towards minus Vset. The steady state value is minus steady state value Vf is minus Vset. Vi is Vd, Vf is minus Vset. After predefined time interval t, state change has been observed. The duration of that time t is equal to t, duration of this time interval t, output voltage V0 is equal to capacitor voltage. Output voltage is V0 is equal to capacitor voltage at t equal to t. At t equal to t. Vi is equal to Vd. Vf is equal to minus Vset. At t equal to capital T, V0 is equal to Vc. V0 is equal to Vc. Therefore, V0 is equal to Vc. Vf is minus Vset plus Vi is Vd. Vi is Vd. Vd plus Vset e power minus t is represented by capital T. Capital T by RC. Capital T by RC. V0 is here in this interval. V0 is at capital T, small t is equal to capital T. That Vc value is minus Vset. Minus Vset. Therefore, Vc is equal to minus beta Vset. Not Vset. Minus beta Vset. At time interval t is equal to t, Vc value is minus beta Vset. Minus beta Vset. Substitute here. This one is minus Vset plus Vd plus Vset e power minus t by RC. Bring to this side plus Vset minus beta Vset is equal to Vd plus Vset into e power minus t by RC. This one is Vset 1 minus beta is equal to Vd plus Vsat e power minus t by RC. E power minus t by RC is equal to Vsat 1 minus beta by Vd plus Vsat. Vd plus Vsat. E power minus t by RC, here some monostable multivibrator derivation is there. Vsat by Vd plus Vsat. Here okay. Reverse this one. E power t by RC is equal to Vd plus Vsat by Vsat into 1 minus beta. Vsat is common term. Vd by Vsat plus Vsat by Vsat is 1. by 1 minus beta e power t by apply natural logarithm. Here ln means log base to the e. Apply ln e power t by rc is equal to ln 1 plus vd by vsat by 1 minus beta. These two are cancelled. T by rc is equal to ln vsat is greater than vd. vd is equal to 0.74. This one is neglected. 1 by 1 minus beta. T is equal to rc ln 1 by 1 minus beta. But beta is equal to r1 by r1 plus r2. r1 is equal to r2. Beta is equal to 1 by 2. Beta is equal to 1 by 2. Therefore, rc is rc into ln by that is equal to rc ln to time period. Natural logarithm. Therefore, t is equal to 0.69 rc. T is equal to 0.69 rc. This is the time period. Specified time interval is t. The monostable multivibrator bring back to that original stable state, permanent stable state.